Well, we're doing section 9.2, and that has to do with first-order linear differential equations. And every first-order linear differential equation has this form: dy dx plus p of x times y equals q of x. And you can refer to that on page 524. And 523 also. And we have an integrating factor here, v of x, and that equals e to the integral of p of x dx. And the solution has the form y equals 1 over v of x times the integral of v of x, the product of v of x, q of x times d of x. So our problem, we're doing 13, and here it is, sine of theta times dr d theta plus cosine of theta times r equals tan of theta. So we don't have this form yet. In order to get that form, we'll have to divide each one of these terms by sine of theta. And then we'll have the form we want. We'll have dr d theta plus cosine of theta over sine of theta times r equals, and when you divide tan theta by sine theta, you wind up with secant theta. So now, given this, let's find v. That's our first task, the integrating factor. So v equals, or let me write v equals, or v of theta equals e to the integral of the cosine of theta over sine of theta d theta. But that just equals, this integral equals ln of sine of theta. And so that equals sine of theta. So v of theta equals sine of theta. Well, that's what we had to begin with. So then the equation we have to contend with is multiplying through every term through by sine theta is what we started with, sine of theta dr d theta plus cosine of theta times r equals tan of theta. So now, if we use the product rule and evaluate the derivative of the sine of theta, which is v, times r d theta, what we'll get is, when we take, using the product rule, the derivative of this, we'll get that. So now we know that r equals, according to what we have here, and or we can say sine of theta, theta times r equals the integral of the tan of theta, which is sine of theta over cosine of theta d theta, or r equals 1 over, dividing every term, each term by sine theta, we get 1 over sine theta, which is cosecant of theta. And the integral of this is ln of secant of theta, absolute values, plus c, and check that out. In other words, carry out and solve the integral. But anyhow, there's our final answer. There's our solution, and we're done.